Hello and welcome to this course on dynamic business modelling. So I'm going to tell you a little bit about what a dynamic business model actually is and show you one of these things and take you through some success cases we've had applying the method and applying the tools to some real situations. I'll explain a little bit about why dynamic modelling is actually needed and tell you a little bit about the modelling process that we will be explaining during the course. I'm going to end up with a little bit about how the course actually works. So let's get stuck into an example of what a dynamic business model actually looks like. We're looking at a company that wants to model the launch of a new product. And we're looking at this from the point of view of an analyst who's got to make the sales and profit plan. And the company has done this kind of thing before and estimates that there could be some 10 million potential customers for the product. And other products like it have succeeded over some 3 to 5 years, or else they've not succeeded and failed to be successful products. They've achieved that by spending something like $5 million per month in marketing, not always the same amount all through the life of the product launch. That starts demand going for the product before word of mouth starts to help that growth accelerate. And the product has new versions coming out all the time. And something like 5% of owners will buy those new versions each month, but only after the product's been out for a while. They're not going to replace the product immediately. The product costs about $180 to make and to supply, but that could fall to as little as $80 or less as the production volume grows. So this is Alan's sketch, it's literally sketched, of how he expects total sales of the product to grow over the 5-year period. It'll take off slowly at first, but then really start to accelerate as that word of mouth effect starts to kick in, and then plateau as most of the potential customers have actually got the product and you're left with replacement sales. And from previous experience and knowing about the cost structures involved, then the company thinks that this is the kind of profit profile that will result. It'll lose money in the early periods when it's spending very heavily on marketing and maybe pricing very competitively simply to get the product going. But then profit should come in later months. So this is a spreadsheet of that product launch. It's calculating the monthly results going down each column, and it's working out profit on the left from the sales and cost items. And I've dropped a couple of charts on here. The first chart combines those two items on revenue and profit growth, and the second chart shows the sources of sales. So the blue line is first time customers buying the product, and the green line is the replacement purchases from people who've already got it, and the red line is the sum of the two. Now you can actually go and get this spreadsheet, go to that link shown there, and you can download the spreadsheet and see what all the calculations are and see how it works. So what does a dynamic model look like, and how is it different from this? Well, here is a working dynamic model of exactly the same case. Now this might look somewhat unfamiliar, and indeed Alan Analyst thinks this is nothing like a spreadsheet, and he hasn't actually built this thing himself. He's had to ask someone else to do it for him, and he's asked his friend, who explains that actually this is exactly the same model. And the way you should think about this, Alan, she says, is just think of each item on this picture as being one of those columns in the spreadsheet, and the link arrows that you can see are like the cell references that tell you what to calculate from what else. But you'll see there's a lot more intuitive information here. You can see how all of the values of all the variables are changing over time. And you can go and get this model from the link shown here, sdl.re/tech2c. And as I say, it is exactly the same model as we just saw on the spreadsheet. So given that this model is the same as the spreadsheet, why would we need this instead of that spreadsheet? Well, there are some big advantages here. First of all, everyone looking at this can see what causes what. I mean, you can imagine people sitting in a meeting room looking at this on the screen, and everyone can see how everything connects to everything else. Everything is crystal clear, and it's not hidden away inside cell calculation. You can, as Alan has done here, sketch in that profit forecast into the profit variable at the bottom of the model there, and the sales forecast is in the sales item in the middle in the blue part of the model. In cases where you've got actual history, you can put actual history values into there. And what you're trying to do is you're trying to get the model, the blue results in these charts, to match the actual or desired data, the red results. If you don't get it to match, then the model's wrong, or you can't achieve what it is you were hoping to achieve in the way you thought you could do it. Furthermore, you can then play out scenarios and choices. If you go to the model and open it and follow the instructions in the model, you will be able to play scenarios with different choices of marketing expenditure and price assumptions. And inside each of those items, there's a very simple language formula. The actual formula is what I've shown there. It's the revenue equals sales multiplied by price. It's not something obscure like $24 multiplied by $24. So it's really easy to see what the relationships are that you have created inside the formulas in these models. Now, sometimes we don't have arithmetical relationships between things. We just know, for example, that as we spend more money on marketing, we will gradually reach a larger fraction of the potential customers. But it's not an arithmetical relationship. It's a kind of sophisticated lookup relationship, much more powerful than you can do in spreadsheets. You can simply sketch how you think marketing reach varies as you spend more money on marketing. And all of this is much, much faster to do with a good modelling tool than you could ever do with spreadsheets. And it's much harder to make mistakes. If the blue line doesn't match the red line, there's a problem. Okay, it's as simple as that. And it's also hard to make cell reference errors because everything that is calculated from something else is connected by arrows. You can't even make a cell reference error in the first place because you can only use things that actually are connected. You can do this with people because it's so fast, and you can do it in real time. You can be having the meeting and actually constructing this model as we're having the discussion. And they will actually enjoy doing it with you as well. This is much more fun than peering at obscure spreadsheets. But if you have to use spreadsheets, and you will still continue to need to use those, then you can link this to spreadsheets if you must. The reason these models work is that they capture explicitly on the screen some critical things. The first of which is that key factors in these models accumulate over long periods of time. We're thinking about things like customer numbers or staffing or product range changes or investments in capacity that change over long periods of time. They capture all of the interdependencies in the system. Everyone says they want joined up plans. Well, this is how to get joined up plans. And when you do the joining up, what you discover is that there's feedback going on. You've got reinforcing feedback driving growth or driving collapse in your business. Or you've got feedback mechanisms that stop you making progress. And the models also capture the thresholds that cause tipping points in the real world. So as the number of owners of this product grows slowly initially, there comes a point where that word of mouth feedback effect causes a tipping point and growth accelerates and piles ahead. And lastly, these models can and should, where relevant, include intangible factors, things like reputation, things like staff motivation and skills, all of which are pretty tough to do in spreadsheet models. So let's look at some success cases where we've actually used this approach in the real world. This one, we'll actually look at this model in the course itself. This concerns travel vaccines. These are the vaccines people get when they're going to exotic parts of the world and might catch horrible diseases. This particular company, it's a division of GlaxoSmithKline, dominated this seasonal market with the only licensed product. So this is the chart here is looking at the seasonal peak of sales that the company would expect to see. The problem is that a major rival product has just been approved, and the competitor sales force will go around our physicians and they will try and take those customers away from us in a very short period of time, and they will do so by charging a lower price. And the fear for my friend who has this problem is that the company will likely lose 80% of its product revenue over the peak season of sales, and this one product accounts for 30% of his division's cash flow. So this is a really serious strategic threat, even though it's only playing out over 15 weeks. What do? We sketched out the kind of relationships on the whiteboard in an afternoon in my office to figure out what a counter plan might look like. We built a model of just right dynamic pricing to give John a chance of actually defeating this attack. And the model also showed the likely effect of tactics that he could use to undermine the rival's product credibility and damage the morale of their sales force. Now, he was all going to lose something in this situation. It wasn't going to be a case of being able to keep all of his sales, but he managed to keep that loss to less than 20% of the sales that he would otherwise have achieved. And this was really fast, and we did this in an afternoon. And John took the model away and continued to use it through the 15 weeks of the competitor's product launch. Here's another challenge. This is a consumer bank starting a popular new business. This is actually providing expatriate banking services for people who've gone and lived in sunnier countries than they come from, but still want to use the bank from their home country. And it's been doing okay for the last 2 years. It has future plans to grow the profits, and this looks really pretty good. It's going to more than double profits over the next 2 to 3 years. But when we put the plan together and the model together of this and figured out what might be achievable, we figured there was much more potential and we could achieve it much faster than the bank's current plans would allow. The model allowed the general manager whose project this was to justify large increases in staffing and growth of the service, to roll it out faster, and a threefold multiplication in the rise in profits that could be achieved over 3 years. And I helped the general manager with this model. They worked on it part-time, a few hours here and there, over about a month. That's the kind of effort that was required to put this together. Here's a very different kind of challenge. This is an investment company looking after people's pension funds, and they are in serious trouble. They're facing closure, in fact, following a downturn in the investment market and following some mistakes that they made during their strategy prior to the downturn in the market. Now, their response to this, typical of companies facing this kind of thing, they announce across the board cuts. Everybody's budget's cut by 20%. That's never going to be the right answer for turning around this kind of situation. And the other reaction was to cancel a multi-million pound investment in IT systems, essential for the future of the business, but that was going to be canned. And in spite of those actions, it was likely that they would still continue with 2 years or more of losses from this business. What we did here was we mapped and modelled the business with the senior team. We identified serious overexpansion in the business. They had launched too many products, they had gone to too many distributors, they were selling to people who weren't investing much money, they had far too many people involved supporting all of these overextended resources in the business. So a focus cutback of something like 40% of the size of the business allowed them to return to profit really much faster, but crucially put the system back into a state where it would be capable of starting to grow again rather sooner. Here's another case. This is in the bulk chemicals industry, facing a serious sales decline because of a rather troublesome competitor they were dealing with. But there was a way that we're able to turn that sales decline around and get it to grow again. This is a functional specific challenge. This is an aerospace business who's losing some of their top technical specialists to the finance industry, and this kind of level of turnover is very damaging to a company of this kind. They really need the experience that comes from these skilled people staying with them for many years, and a dynamic model showed how it was possible to change the way in which people were hired and developed and recruited and rewarded to radically reduce the turnover of those staff. There's a few more examples. This heating equipment distributor was facing a maturing market, but rather than kind of go down with everybody else as the market saturates and sales slow down, he was able to help his competitors fail rather more quickly and pick up business from their failures. In the power distribution industry, there's been a long-term decline in equipment reliability as companies have desperately tried to keep generating cash flow. And this case allowed us to reverse that long-term fall in reliability while still maintaining acceptable cash flow rates from the business. We will actually look at this case. It's a slightly different example of a new tech startup than the Alan Analyst problem we looked at earlier. But this one too is all about accelerating market penetration for a new technology product in the Internet of Things industry, the IoT sector as it's known. The method works perfectly well in public services and non-profit cases as well. This example looked at anticipated large-scale staff shortages in nursing, and this corporate law firm was really trying to kind of productize its services and hire different kinds of lawyers to support the rollout of these new services. In general, though, we are always looking at three common questions. The first is, why have we got to here? Why has performance been what it has been? And that's important for two reasons. First, it tells us how the system actually works. We need to get the model to replicate reality. If we don't do that, then our model is not reliably reflecting what's happening in the real world. The second reason we need history is that things that have already happened in the past are already affecting what will happen in the future, and we need to track the trajectory of those past decisions and past events that will be affecting our future. We then go on to the second question, which is where performance might be going if we carry on as we are with business as usual. And of course, what we really want to figure out is how to improve that future and get a better result out of it. So those three questions are generic in many cases. The only exceptions are where we're looking at new ventures or new initiatives or new issues where we don't actually have any history. So we're kind of starting at the now point on this chart. But we still want to answer the second two questions. Where might performance go with the plans we currently have, and how might we get better results in the future? A word or two now about why this dynamic modelling approach is actually necessary in today's world. Very generally, what we do is we figure out a strategy for doing something, a strategy for a business, and we try and use other methods for describing the business model of what that strategy is. And those methods typically help us decide who we're going to try and serve with what products and services and how we're going to do it. But we need to get these financial and other results out of that strategy. The problem is that we don't have any tools to get from the strategy to those results. What we need in the middle is we need to translate the strategy into time-phased action plans. Who is going to do what, how much, when, in all functions, with what outcomes, and how are we going to adapt those plans as events unfold? Only then can we figure out what the financial results are going to be, because those choices we make will have costs, and those costs have got to go into the financial results. Those outcomes will be growth in sales and growth in revenues, and those will go into our financial results. You just can't get to financial results if you don't know what the time-phased action plan is going to be that's going to generate those results. What we then do, of course, we grab the key performance indicators from the business as time passes by, and we go back and we figure out how to change that action plan. Problem is, if you don't know how the system actually works quantitatively, it's very hard to figure out how to adapt that action plan. So our KPI systems and our balanced scorecard systems may be fantastic in themselves, but if we don't know what to do about what they tell us, we're a bit stuck. Now, how does a system view solve that challenge? Well, we start by recognizing that any enterprise is what we call a designed system. Someone or some team has actually figured out how to make things work. They may have done it intentionally, or it may have been put together intuitively. So what a model helps us with, it helps with three things. Firstly, it helps us explicitly design the system so that if it worked the way we expect it to work, it could perform well. It has the potential to perform well. But we don't stop there. when we're actually running the system, when we've started a new business or we've started on the initiative or we're adapting the strategic plans for the function or for the business, the models help us manage the system continually. It joins up those performance indicators back into the action plan, so the business actually does perform well and fulfills its potential. Now, things will of course go wrong, and then the model comes in and helps us a third time, because it helps us figure out how to actually fix the system if it goes wrong. Now, we can do this at any level. We can do it for the whole organisation. That investment company facing the profit crisis, we had the whole management team right at the top of the organisation working together to figure out how to crack the problem. Or we could do it for any part of the organisation. The vaccines problem was essentially a marketing and sales challenge. We can use the models, though, for two purposes at either of those levels. We can use it to tackle one-off issues. So both the investment company's profit crisis and the vaccines competitor threat were examples of one-off issues. It could be to do with fixing problems or dealing with threats, or it could be about taking opportunities, entering new markets, launching new products, or implementing initiatives, maybe some kind of strategic change that we're going to run through the business. Or we can use it to develop and manage a continuing long-term plan. So Alan Analyst's product launch there, that would become the continuing long-term plan for that product, and it will continue to be useful for as long as that product is being sold into the marketplace. Just a word about the process by which we create these models. And for anyone listening who is familiar with system dynamics modelling already, I should just say that there's a somewhat different philosophy that we are going to follow through this course. Now, that philosophy is what we call an agile approach to modelling. It's a style of model development in which a working quantified model is built fast. We do it quickly. We get something working in a very short time with the users, and that model is repeatedly added to and extended to the extent that we need to. And we don't always need to keep adding and extending the models. And we do this with a continuous involvement of the users or the clients, the people who actually have the problem. If that's us, of course, then we're naturally involved, but often we're doing this with other people or for other people, and they must be involved through the process. What this approach does is it gives insights and actionable findings at every stage for reasons I'll explain in a moment. That you may be familiar with other approaches to modelling in which you build qualitative diagrams and maps and causal loop diagrams of the situation or the issue that you're trying to model. There is no qualitative mapping in this process. It's one of the reasons that the process is much faster. And there's an article you can go to and read there to explain about that. And in that article, it explains that the approach is named after an equivalent fast development approach that's been used for many years in the IT world to help IT developers build IT system solutions for people and actually with people rather faster than traditional planned approaches to IT systems development. So that's where the agile word came from. The steps in this process, we start by setting out with the problem owner what the performance over time is that we're trying to improve. We trace back from that to what are called the stocks that are driving the performance, the customers driving sales, the staff driving service capacity and labour costs. And we then look at how those stocks are accumulating and depleting over time, driven by what are called the flow rates. So how fast are we winning customers and losing customers? And what does that do to the stock of customers changing over time? How fast are we hiring staff and losing staff and promoting staff through the staff pipeline? Very similar to the way in which your cash accumulates in your bank account or the debt rises and falls on your credit card. What we then do is we look at those flow rates, the customer win rate or the staff turnover rate or whatever it may be, and we trace back to what's driving that, and it's usually some mix of decisions that we've taken or external factors that are affecting us or existing stocks in the system. So, for example, we would lose staff if the number of customers was generating so much demand that our staff were overloaded. So that's an example of interdependence. And when we trace those interdependencies around, what we discover is that there is feedback in the system. We have that word of mouth feedback for that consumer technology product that we discussed with Alan's case. But then we've got other kinds of feedback, like the balancing feedback that causes the limits to just how far that particular business could grow. And reinforcing feedback can cause bad things too. That investment company was in a serious decline because there was a negative feedback in the system driving down their sales and driving down their profits. The important thing about this process is that the user gets actionable results at every stage. In some cases, it can be a matter of minutes before you've discovered something important about the relationship between changes to a customer stock and what's actually happening to your sales performance. And then at the next stage, you get further actionable results. We've got problems with our sales, not because we're failing to win customers, but actually because we're losing customers at an increasing rate. Actionable results again, and then you get further actionable results when you see the relationships between these decisions, external factors and existing stocks. Now that gets you to a start point. You get a kind of core basic picture of the working system when you do that, and sometimes you need to go back round it once or twice more to fill out some of the missing mechanisms in the business, but you don't often have to go around it very many times. When you've done all that, what you end up with is a reliable working model that can be continually updated and exploited. This should be a working tool that you keep on using. Now, it's important to understand that we could not have done this until recently. Things have changed. Simulating business systems and performance up until recent years was genuinely difficult. The method was time-consuming, laborious, it required a lot of experience, and it was often unreliable. We ended up with models that people didn't trust and didn't give reliable results. But with the better methods that we have now and the better tools that are available, this is now a very practical thing to do. It's easier, faster, and more reliable to build these models using these tools than it is to do a worse job using spreadsheet-based alternatives. That's the real bottom line benefit that you're going to get out of this course. Now, how does the course work? Well, if you're taking the self-taught course, you have access to video slideshows that explain the principles, and they provide instructions for you to follow so that you can actually build models yourself, matching the models that we show you in the slideshows. And we provide you with the correct models that actually match those solutions. So you can compare what you end up with the models that we've produced. And some of those models actually develop from class to class. So we start with a simple model in class 1, we add to it in class 2, add to it in class 3, and so on. And there are many more working models that we will show and share with you during the course, and worksheet models as well that are kind of blank templates. And what these do is they allow you to start your own models. You don't have to start from a blank sheet every time. We have done very, very large numbers of models for differing industries, differing cases, different functional topics, different issues. So it's very likely that we've already got a model that is very close to a situation that you have. And so you can start your own models from some of those working models and worksheets that we provide. And you can follow all of these materials and activities at your own schedule. If you're really keen, you can do a class every morning and every afternoon and be through it in no time at all, or you may want to spread it out over a few weeks or even months. That's entirely up to you. If you take the instructor-led course, you get all of those same materials from the self-taught course, but we also share with you the classes from the Strategy Dynamics course that explain the wider principles. And these are typically most useful for senior managers. Senior managers do not spend their time poring over computers and building simulation models. Their colleagues do that for them and with them. But it's important to understand that senior management perspective through these frameworks about how business systems generally work, and that's what those additional classes are about. You also get access to a discussion forum to post questions and comments, and we provide webinars to discuss and clarify modelling issues from your cases. Now, of course, for all of this to work, we've actually got to follow this in scheduled classes, typically weekly. So we'll do a class a week and probably run the webinars on a Friday, for example, and try to match them to your time zone as well. However, the materials are still available to you all the time and continue to be available after the course is over. So you can again go back and review these at any time that suits you. Just one last word about software. I explained that simulation tools have been pretty challenging to use, but we use the Systea browser-based software, which you can find at systea.com. And you might like to just take a look at the video user guide at that link, sdl.re/SYG-full. It's been purposely designed to be as easy as possible to use and accessible. It's very easy to get at. It runs in your browser. You don't have to install anything. And anybody you share models with doesn't have to install anything either. They can just run it immediately. And access to this software is included during the course and for a short time afterwards as well. However, we should say that most of the principles in this course can be replicated with other software that builds these system dynamics models. So thank you for listening to this explanation of the business modelling course, and I do hope you find that the course is useful and helpful to you in your professional life.